For our first problem, we're given a geometric series and that it is equals to k. So we have to determine the value of k if the series has 25 terms. So here we have to first determine the constant ratio. So r equals t2 over t1, which is also equals to t3 over t2. So that will be equals 5 over 16 divided by 5 over 8, and the other one for t3, 3, which is 5 over 32, 32 divided by t2, which is 5 over 16, 5 over 16. So our constant ratio is 1 over 2, 1 over 2. So now let us determine the general formula. So Tn equals a the Rn minus 1. So a, which is the first term, our first term is 5 over 8. We have 5 over 8 into r. Our r is 1 over 2 to the power n minus 1. So now we can determine, as we have seen here, that k is the sum of this series. We can determine the sum of the series. So S n equals a into 1 minus r to the power n over 1 minus r. So in order to use this equation, the value of r should not be equals to 1 and r should be less than 1. So this is to mean that r should be a fraction. So it's easier to use this formula when r is a fraction. So substituting the values, we have a, which is 5 over 8 into 1 minus 1 over 2 to the power 21 all over 1 minus 1 over 2. We're raising the value of r to the power 21 because we were told that there are 21 terms. So therefore the sum Sn, which is also equal to k, equals 1.249, which is equals to 1.25. So our second question says determine the largest value of n for which Tn is greater than 5 over 8192. So we know that Tn or the general formula equals a times r to the power n minus 1. So for we can substitute this expression for Tn, and we will have a times r to the power n minus 1 is greater than 5 over 8192. And we know from the first question that our constant ratio is 1 over 2 and our first term is 5 over 8. So we can go ahead and substitute these values. So substituting, we have our a, which is 5 over 8, and r is 1 over 2 to the power n minus 1 is greater than 5 over 8192. So therefore the question said that we should calculate the value of n for which Tn is greater than that value. So now we can calculate the value of n. So we will go ahead and divide by 5 over 8 on this side, and we will divide by 5 over 8 on this side. So that will cancel that, that will cancel that, and we'll be left with 1 over 2 to the n minus 1 is greater than 1 over 1024. So what we can do here is, let's keep this expression, and we'll have 1 over 2 to the power n minus 1 is greater than, well, this is 1 over 2 to the power 10. So now we will change the fraction to a number, and this is a law of an exponential law that says if you have a variable or a number, let's say d, and this number has a negative 1 to the 8 power, a negative power, this number can be written as 1 over d. So this is an exponential law. So we can change this and say 2 to the power minus 1 to the n minus 1 is greater than 2 to the power minus 1 times 10. So now we can see here, and this is an exponential law. If the bases are the same, we can equate the powers, or we can take the powers. So that is minus 1 times n, we have minus n, minus 1 times minus 1, we have a plus 1 is greater than minus 10. So we can take 1 to the right hand side, so we have minus n is greater than minus 10 minus 1. So minus n is greater than minus 11. Now we can divide by minus 1 and divide by minus 1. Now this is a law of inequalities, and it says when you're dividing by a negative number, you should change the inequality sign. So now we have n is less than 11. So therefore the value of n that is less the value of Tn the value of n for which Tn is greater than 5 over 8192 is equals to 10, because that value it should be less than 11, but it should not be equals to 11. Our next question says, for the first two terms of a geometric sequence, x plus 3 and x squared minus 9. And the question says, for which values of x is this sequence going to converge? So what we need to get here is the constant ratio, because we know that the condition for convergence has to do with the constant ratio. So R equals T2 over T1. So T2 is x squared minus 9 over x plus 3. We can simplify this. On the numerator we have a difference of 2 squares, so this can be written as x plus 3 into x minus 3, all divided by x plus 3. Well, we can cancel these two terms, and then we'll be left with r equals x minus 3. As we have seen earlier, the condition for convergence says r must be between minus 1 and 1. So now we can substitute the value of r, which is x minus 3 here, and now we can solve for x. Now we have minus 1, taking the minus 3 to the left hand side, we have plus 3, and we'll be left with an x inside and a 1, and then taking 3 to the right hand, to the minus 3 to the right hand side, it will be a plus 3. So minus 1 plus 3, that's a 2 x, and 1 plus 3 is 4. So the values of x for which this sequence will converge are between minus 2 and 4. The next question says, calculate the value of x if the sum of the series to infinity is 13. So now we need to calculate the value of s. So we have s to infinity equals a over 1 minus r, and we're told that this is equals to 13. So now we need the value of a. Well, a equals the first term, or t1, of a sequence, and this is equal to this expression here, x plus 3 equals x plus 3. And also we'll need r, which is we've already found that r equals x minus 3, x minus 3. So now we can substitute these into the formula, and calculate the value of x. So we have a whose x plus 3 over 1 minus 1 minus x minus 3 equals 13. So now we should just find the value of x. So we have x plus 3 over minus x. So minus times minus 3, that's positive 3, so that's going to be plus 4 equals 13. So now we can go ahead and cross multiply. So we have minus x times 13, that's minus 13x. We have 4 times 13, that will be plus 52 equals x plus 3. So taking x to the left hand side and 52 to the right hand side, we're left with minus 13x minus x equals 3 minus 52. So that will be minus 14x equals 3 minus 52, that's going to be minus 49. Divide by minus 14 and divide by minus 14, and we'll cancel 14 aside, so we're left with x equals 49 over 14. So that's your value of x. Our last question says the sum to infinity of a geometric series with positive terms is 4 1 over 6. So the sum to infinity equals 4 1 over 6, and the sum of the first terms is so t1 plus t2 equals 2 over 3. Now we are supposed to find a, who's the first term, and r, who's the constant ratio between the consecutive terms. So let us write these fractions in these mixed fractions in a proper fraction. So 6 times 4 is 24 plus 1, that's 25. So we have 25 over 6. And here 3 times 2 is 6, plus 2 is 8, so we have 8 over 3. So we know that t1 equals a and t2 equals a times r to the power 2 minus 1. Now this is equals to a times 2 minus 1 is 1. So this is equals to a times r. So we can say t1 plus t2 equals t1, which is a, plus t2, which is a times r, and this is equals to 8 over 3, to 8 over 3. So we can take this equation here and solve for a. So if we solve for a, we will have a into, and we'll factor a from this expression here. So we'll have 1 plus r equals 8 over 3. So a will be equal to 8 over 3 into 1 plus r. Now let us look at this equation here as to infinity. So the equation or the formula for s to infinity equals a over 1 minus r, and this is equal to 25 over 6. So now we can take this equation here and also solve for a. So in doing so, we have a over 1 minus r equals 25 over 6 multiplied by 1 minus r. And what you do on one side, you do on the other side. 1 minus r. So this will cancel that, and we'll be left with a equals 25 into 1 minus r over 6. Now we can equate a. So a will always be the same. A is the first term. So we can say a equals a, and our first a, which is this one, was 25, and you can choose either one, into 1 minus r over 6 equals our next a, which is this one, which is 8 over 3 into 1 plus r. Now we can go ahead and solve for r in this equation. So we will cross multiply. So we will have 25 into 1 minus r multiplied by 3 into 1 plus r equals 6 times 8, that's 48. Now let us distribute 25 and 3. So we will have 25 times 1, that's 25. 25 times 1 is r, that's minus 25r. Now 3 times 1, we have 3. 3 times positive r, that's plus r, equals 48. So now here we have a difference of 2 squares, so we can just multiply. So 25 times 3, that will be plus 75. That is 25 times 3. And minus 25 times r, that is going to be minus 25r squared equals 48. I hope you know how difference of two squares work, and we have already talked about them in previous videos. So now in simplifying, we have an error here. I've made an error here. Sorry. So this will be 25 times positive 3r. That is 75 r squared. So we have minus 75 r squared equals 48 minus 75 divide by minus 75 divide by minus 75. So we can cancel 75 here, and we'll be left with r squared equals 27 over 75. So now we can just take a root of each, so we'll be left with r equals plus or minus 3 so that is 3 over 5. But now, as the question said, we're only taking the positive looking at the question here. The question says the sum to infinity of a geometric series with positive terms. So we're looking at only positive terms. So we will consider r equals 3 over 5. Now, in order to get a will be equals to, we can take any of the equations that we have established for a. So we can go ahead and take a, this one, which says a equals 8 over 3 into 1 plus r, and equals to 8 over 3 into 1 plus 3 over 5, because we've already defined that r is 3 over 5, and a will be equals to 5 over 3. And just like that, you've completed your solution. I hope you have learned from this video, and I thank you very much for watching. If you're still here, you're awesome. And still, if you're still here, please leave a comment and tell me if these videos are useful to you or not. And also, if I made any errors in the videos, please tell me about them. I will then fix them.